The other side of the room, 3b. Okay, let's talk about 3. So for 3b on this, you're trying to find the antiderivative of this. So another way to answer that question is, this right here is the derivative of what? That right there is the derivative of what? And this is where you need to remember some basic trig derivatives. What's the derivative of sine? Do you remember? Cosine. That's correct. And what's the derivative of cosine? Negative sine x, right? So you're thinking that is the derivative of what? So sine is the derivative of what? So what does this go up to? Negative cosine of theta. That's correct. Minus, that 4 is just along for the ride. The derivative of what is cosine? The derivative of what is sine? And then what do you plug onto the end of this? Plus c. That's it. That's all it is. Because the derivative of cosine is negative sine. What's negative sine? Regular sine. Oh, what's in front there? I'm sorry, I lost the 3. It should be negative 3. I'm very sorry, I forgot the 3. It should be negative 3. Do first. What do you think you should do first on D before you integrate? Simplify is not quite the right word because this is technically, like, it's debatable what the most simplified form is. But instead of radical form, let's write it in exponent form. So this is going to be the integral of t times t to the what power? 1/2 plus 1 over t times 1 over t to the 1/2, like dt, right? So I'm doing this in pieces. We're not done simplifying. This is t to the first. What is t to the first times t to the 1/2? T to the what? 1/2. So I like saying t to the 3/2 is what I would say. Plus, this is t to what power right there? That's t to the, and this is t to the negative 1/2, right? So I have not done any calculus yet. What do we do with these two powers? You do what to them? Add them. So what does this become? The integral of t to the 3/2 plus t to the what? At this point, is there any other simplification we can do? First piece right here. T to the what power? Close. Not 4 over 2. Come on, what's 1 greater than 3 over 2? You have to go up 1. 5 over 2, and then what is it all over? Come on, we've done this so many times. Over 5 over 2, because you have to get rid of the 5 over 2 when it drops to the front. So then what's this one become? Plus t to the what power? Negative, no, go up. You have to go up. Negative 1/2 over negative 1/2 plus c. Now, can you simplify this? Sure. What does this become? 2/5 t to the 5/2 minus 2 times t to the negative 1/2 plus c. I love this intermediary step. This is really important right there. It makes it so you far less frequently make a simple mistake. If you take the derivative here, the 5/2 cancel, that becomes 3/2. If you drop this down, it becomes positive, which is what we want. The 2 cancels and it becomes negative 3/2 to the power. Do it piece by piece, please. Right there, what's the fourth word? Area. So it's not just an integral. You have to be really careful about that, right? Because if you integrate when it goes below the x-axis, it'll be negative. Area is never negative. So what do you need to do on this first? What's a really good thing for you to do first? Draw the graph. So it says find the exact area between the x-axis and the curve f of x equals 3 sine x from 0 to 2 pi. So if you graph this, so you're graphing y is equal to 3 sine x, where does it start? What's sine of 0? Come on, what's sine of 0? 0. And sine, does it go up or down from there? It goes up. So this thing will go up and then down like this. How high does it go to, by the way?
1.
Careful, there's a 3 in front. It's going to be y equals 3 right there. So this is pi and this is 2 pi, correct?
Mm-hmm.
So there are 2 integrals you have to do. There's this one right here, but then where's the other one? Below, correct? You see that, everybody? Okay, so what's the first one right here? So if we want to do the area of this first one, what's that going to be? That's going to be the integral from what to what? 0 to pi of 3 sine x dx. Do you agree with that?
Yeah.
What's the area of the next one going to be, though, if we do this one? If you just did this, why would this be problematic? Pi to 2 pi of 3 sine x. What's the problem with that? That would be negative, right? Because it's below the x-axis. How do you fix that? What's the easiest way to fix it? Don't say absolute value because you're doing this by hand. How do you make a negative positive? Put a negative in front of it. That's all you do. That's all you do. So now, what can you factor out? Let's do the top one here. What can you factor out right there? 3 integral from 0 to pi of sine x dx. What is the integral of sine? We figured that out. What is that? What is the derivative of what is sine? Negative cosine of x, and you're evaluating it from what to what? 0 to what? So you see that negative? We can pull that out with the 3. So how could we write this? It is negative 3 times cosine evaluated from what to what? 0 to pi. So that's going to be negative 3 times cosine of pi minus cosine of what? This is where you have to know your basic trig. What is cosine of pi? Anybody remember what cosine of pi is? Please tell me you remember what. Raise your hand when you know what it is. You have to know it. It's not that much more work because it's the same function twice. Just be careful that you've seen before. There might be one thing in there that you haven't seen. There might be one thing in there that you haven't seen. But this is what you really, really have to remember here. There are 4 things there. Take a look at what it says. That therefore means the integral of 1 over x is ln x. We don't prove this. There's actually a ton of stuff we don't prove in calculus that you just get to use, which is fine because you get to go and do things with calculus. And then if you take more math, there's a whole field of math called analysis, real analysis, and most of that real analysis is proving why calculus works. It's really cool stuff.
The x always has to be an absolute value.
And that's really important. It needs to be absolute value. It's important because can you take the natural log of a negative number? No. It has to be absolute value there. So what is the integral of secant? Well, tangent. Because what's the derivative of tangent? Secant. What's the derivative of negative cosine? Sine. What's the derivative of sine? Cosine. This is the opposite direction. Effectively, all you're doing is taking things you know in one direction and going in the opposite. So for example, these two right here. How about you go to the board right now, find a marker space, and do these two right here. Yeah, so this one right here, what do you get here? 2x cubed over, right? Plus 3 ln of absolute value of x plus 6x to the negative 1 over plus c. What about this one? 5, what is it, tangent x minus 4 sine x plus 2 cosine x plus c. You're good with those?
But can you go to the A? Because
Yeah.
the 6.
The first one you have to be really careful because you have to remember that if you have f of g of x and you take the derivative, what do you get? F prime g times what? Do you remember what it's multiplied by? G prime of x. That's what you just did. This is the what rule? This is the chain rule. And this is the chain rule, and this is for differentiation, not integration. Undoing it is very different. So we just figured out that the derivative of this is 2x sine of x squared. So therefore this must be negative cosine of x squared plus what? C. Do you see the parentheses around the x squared right there? Do you see those parentheses? I really like those parentheses. Why? Because you're squaring just the x. You're not squaring the cosine as well. Be very careful about that.
So what if we don't notice that it's like in derivative form?
Well, you need a point and a slope for this, right? That's what you need. So what's the easier one to find? Point. So you know the x value is pi over 4. So what do? You have to plug in pi over 4 into the function. What is that going to be? 3 cosine of 3 pi over 4 plus 4. So there's your point. Congratulations. But you're not done with that yet. For your slope, you need to do pi over 4, comma, f prime of pi over 4. So some of you found the derivative, which was great. What is f prime going to be? Negative 9 sine of 3x. I think all of you got that? So you're looking for what is negative 9 sine of 3 pi over 4. So it all comes down to knowing your basic trig values, right? On the unit circle, there's really only 2 triangles you need. The first one is for 45 degrees. What's that point right there? If this is 1, what's that point? Oh, it's root 2 over 2, comma, root 2 over 2. And then there's only one other one you need, which is not 45 degrees, it's the 30 degrees. What's that point right there? Oh, it's root 3 over 2, comma, 1/2. Everything else you need to know on the unit circle is just a reflection of those points. That's it. So on a unit circle, where is that right there is what? How many degrees is that? 3 pi over 4, which is how many? It's 135 degrees. 3 times 45. What is this point? What is that point? Close. It's root 2. It's negative root 2 over 2, root 2 over 2, because it's in the second quadrant. So what is cosine of 3 pi over 4? What is cosine of 3 pi over 4? Negative root 2 over 2, because it's the x value. And what is this one right here going to be? Oh, it's negative. Oh, this is, what's that one? Root 2 over 2. So your point becomes pi over 4, comma, 3 times negative root 2 over 2 plus what? 4, right? And what's your slope? The slope is going to be negative 9 of what times what? Root 2 over 2. So when you write this, you know it's y minus y1 is equal to m times x minus x1. So what is it? Y minus what? Negative 3 root 2 over 2 plus 4 equals negative 9 times root 2 over 2 times what? Pi over 4, yes. That would be your final answer right there. The only thing that should be a little bit, I'll accept a little bit of friction right now because we haven't done trig like yesterday, but you need to remember basic trig values. Basic trig values. You have to remember things like that. So like, how many degrees is pi over 3? How many degrees is pi over 3? 60 degrees. Pi over 2 is? 90 degrees, right. Pi over 4 is what? 45 degrees. Pi over 6 is? You need to know those things and then all the multiples of them. If you remember these right here and you remember these triangles right here, you're good because everything is a reflection of that. Or a you just rotate it around. That's it. The long side on a 30, 60, 90 triangle is root 3 over 2, right? So if you flip it over, it's going to be negative root 3 over 2. Yes?
Say the same for sine.
You're going to write, you could write 2 times 0 to pi of sine x dx. And that's going to be 2 times, what's the integral of sine? What's the integral of sine? Negative cosine x, and you're doing that from 0 to pi. So that's going to be negative 2 times cosine of x from 0 to pi. It is super easy to mess things up. So you're going to have cosine of pi minus cosine of 0. You'd write out each step and end up with cosine of pi is negative 1 minus, what's cosine of 0? 1. So you have negative 2 times negative 2 is 4. Write out each step. I know each step is not very hard, but if you miss a step, it goes boom, goes away quick. Very hard. Okay.